All right, g'day year 10s. I've just thought I'd record this to help those of you that are still trying to figure out the skateboard part of the quadratics folio. A little video here should help you figure out how to select different sections of different functions, so it ends up looking like a skate ramp or a half pipe, sorry. So you can see here I've got my, I don't need any of this. I'm just going to get rid of some of this so it doesn't distract me. Don't need that survey, don't need this. All right, here we go. Sorry about that. Okay. I've got a quadratic. You can see that it is this quadratic here. It's f of x is equal to x squared minus 5x minus 1. So it's graphed on Desmos for me. This is what it looks like just here. And if you, just a couple of things to help you remember some things. Graphically, we would say y is equal to f of x. So y is whatever f of x equals, and x is just the number that lines up with the x axis. So to get y at any point, we follow the rule with whatever number that adds up to with x. Okay, so what I want to do right now is we've got this quadratic, and if you imagine like maybe this curvy section here, we can imagine that maybe that is the drop-in that we want to do on one side of it. So I've picked some points for myself that are on this quadratic. They're there in orange. I might label them actually. Okay, so I've got these 2 points. This point here, 1/2, 0.5, and negative 3.25. I've got it in fractions over here, by the way. It's there for you in decimals. It's the same numbers. So positive 1/2 and negative 3.25 might be like the top of my drop-in. And then 2.5, negative 7.25 might be right at the bottom of the drop-in before it hits the flat part that heads this way. So this is the part of the skate ramp that I want. And obviously the function as it's drawn is like all of this graph, right? This whole parabola, this whole quadratic. And we want to get rid of the bit that's too far to the right and the little bit that's too far to the left that's too high. So I've got my points there. Now, what I want to think about is just this x value here for a minute. Maybe you can see I'm kind of hovering over 1/2 on the left-hand side of my screen. And I want to think about just the x part, this point. So to help me think about just those x parts, I've kind of lined up dotted line for myself that goes with just the x part. Imagine if I was dealing with the y part, there'd be a line going, horizontally, lefty righty, but I don't want to do that right now. I just want to think about the x part of the coordinates. I've put in x equals 1/2 and it gave me a line just there. And I wanted x equals 2.5 and it gave me a line just there. So I just want this section in between here. So in a general sense, if I think about, I'm going to get rid of my points here now. I know that I'll get rid of the labels too. I want the section that's in between these two lines here. So I'm just going to show you what the whole section is. Like if I think about the entire section of all the Cartesian plane, like I could zoom out a little bit here. This is all of it going off towards positive infinity and down towards negative infinity. Doesn't matter what number you imagine. That orange section is always between this number of x's and this number of x's. It's the section in between those two values. So the way we write that is x is less than or equal to 5.5. It's great. That's that side. That's this line on the right hand side. Actually, I might get rid of the other one so it's really obvious. I zoom in here. This is the line of x is equal to 2.5. That's that one. X is equal to 2.5. It says it just there. That's that dotted line. Well, x isn't allowed to be bigger than that. It can't be over here. It's got to be less than that or equal to it. So that's this bit of domain notation just here. And the other thing is, if you think about the other line, I'll put the other one in, turn this one off. So if we think about this line on this side, well, what I've got here is The rest of, like, it's got to be greater than that number. So it's got to be to the right-hand side of 1/2. When we combine these two things, it's greater than 1/2, greater than or equal to 1/2, I'm sorry, and less than or equal to 2.5, or 5/2 is a fraction. So that's the section that we want. So all that we need to do is take our quadratic. Here's our quadratic again. That's the same quadratic that I've got. And what I've done is I'm just going to turn off this orange section now. What I want you to notice is I'm taking this information here and I'm putting it inside the squiggly brackets, which is domain notation brackets. I'm going to just turn that bit on, turn all this extra stuff off. We don't need this now. Off. Okay. And I'll turn off the whole quadratic. And what I'm left with is, what happened here? Why have I got this twice? Hello. Let's call that. What happened here? Interesting. Oh, less than or equal to, I'm missing a symbol. There it is. Now let's turn this one off here. We don't want that one. What have I got on? I've got something else turned on. There it is. Sorry, I was doing something else with someone else earlier. Right. Well, that was frustrating. Okay. Let's just, sorry about that. I was doing, there was just a little shout out to Rory and Braden, who came in before I recorded this, and I showed them something using this line here. Whoops, sorry, this line here. I forgot to turn it off. So now it's off. Right, let's think about what we just did. This was my original quadratic. That was the whole thing. This red one down here is the part of the quadratic that is just in between these two values. That line and that line. So it's in between those two values. That's all of it. And that's all of it that applies to this function just here. Okay, so if I just want just that section, now I can turn off the whole thing and I'll have just the red of line that I want, which is like drop in on my little on my skate ramp. So there we go. That's how we cut off sections. Now I'm just going to keep going here for a minute and show you one more thing. The next thing I want to think about here is, I'm going to put this dot on, by the way. There's a dot down the bottom. This is the turning point of my quadratic, and I found this by observation. I just like kind of clicked on it and it told me what it was, and then I typed it in. Now I've got the dot. Now what I want is I want a flat of my skate ramp. Now a horizontal line lines up with, look what axis it hits, it lines up with some value of y. This is the y-axis over here, and the value of y that it lines up with is this bit. That part of that's the y part of that dot. So what I'm going to do is I'm going to put in an entire line, lines up with the y point of this. So this point lining up with where it lines up with the y-axis, which is y is equal to that whole thing there. So I'll put it in, you can see the whole line. We've got the same issue we had a moment ago. We don't want the whole line. So let's say, let's try and figure out where we want it to go. And I'll show my x-axis as well. So I've put, this is the one I had before. It lined up with this point here. This point here. 5.5. I just put that back in again. So I've put that line in. I definitely want this bit to the right of it, and I want to cut it off somewhere. So this is 2.5. I decided maybe I want the base of my skate ramp to be units long. So I'm going to put another line over here, which is 10.5 or 21/2. So I'll do the same as I did before. That's the section in between. It's bigger than, greater than or equal to 5.5. Sorry, I keep saying 5.5. It's 5/2. 2.5. I'm sorry about that. And it's got to be less than or equal to 21 over 2, which is 10.5. So we're just going to take the same line we had before, put this information, the section we want, in the squiggly domain brackets. And when I turn this on, I turn all the other ones off. That's the whole line. That is the whole line. And this is the same line in between the brackets. So if I turn off the whole line, I just leave that's got the correct domain notation in between those two bits. I get the flat bit of the skate ramp that I want. And we're done. I'll record another video in a minute showing you how to get the upside over here, because you need to, I've done it 8 units to the right, which is a bit of a hint for you, but I'll just give some reminders on some of these transformations. So we want whatever quadratic gives me the exact turning point, 8 points to the right over here. I'll do that in another video.